Yeah. After that, we will move on to looping. Sorry for the typo here. It says decision making, but it's actually loops. We will talk about different forms of loops, which come mainly in these two forms: a while loop and a for loop. We will talk about what is a while loop and a for loop, and we will see some examples there. After that, we will move on to object-oriented programming concepts, which are again very basic to Java, because Java is an object-oriented language. These concepts are inheritance, encapsulation, abstraction, and polymorphism. Uh, we have some examples already lined up for these topics, so I will just take you through those examples, and any questions that you have related to the topic, feel free to ask. If time permits, after that, we will talk about Selenium. We will talk about what Selenium is and what Selenium is not. So we will clear the confusion about what Selenium can do and cannot do. And after that, we will talk about WebDrivers. We will try to understand what WebDriver is. And after that, I will show you how to download Selenium jars so that you can use it in your projects. So this will be the topics of discussion today. And let us move on to the individual sections. So the very first topic is access modifiers. So as we discussed yesterday, we talked about the private and public access modifiers. So while creating our variables, you would have noticed yesterday that we were putting keywords like public and private. So these keywords are actually very important for any data type, because this defines the scope of a data type. It tells us how much visible this data type will be, and to the different classes in different scope levels, what are the classes which will be able to access these data types. Now this is very important because this invariantly defines the object-oriented architecture of Java. This allows us to make object-oriented programs. So the very first data type, just give me a minute, I think. Yeah, the very first access modifier that we will discuss today is the default modifier. Now the default modifier has no keyword. If you don't write anything like public or private, it will mean that it is a default modifier. So if you leave the access modifier blank, it means the default modifier. And the accessibility, it will be accessible to all the classes inside that particular package only. So if it is a default modifier, it is only visible to the classes inside the package. So let me give you an example here. So I have created a small class called just a minute. I have created a small class called car, which has it's a very basic class. It has just two member variables which are of type integer, and the names are tire count and engine size. So this class has just two variables, and you will notice that I haven't put anything in front of the classes or the variables. So this means that they are default modifiers. Now these all the objects with default modifier type are only visible to other objects inside the package in which this class resides. Now as you can see, this class resides in a package called access modifier. So nobody outside this package will be able to access it. We can prove this fact by looking at the code here, looking at the project here. You will see that there are two packages inside this project. One is access modifier and the other one is package 2. So if I try to access car class outside access modifier package, I won't be able to use it. So let me show it to you here. So this is just a main method, just a simple program class which has a main method, and I will try to create an instance of my car class. Now before I create the instance of my car class, I have to import the package in which my car resides, and as we have seen here, my car resides in a package called access modifier. So this is the statement to import a package. All you have to do is just type import space followed by the package name. And I will show it to you. If you put a dot after that, you will see, just a minute. If you put a dot after that, you will see that it will list down all the classes inside that particular package. Just a minute. It says access modifier. Yeah. And after that, if I do a dot, it will show me all the available public classes and variables in that package. So right now we have a custom car, we have a custom subclass, a hatchback and a SUV car, but we don't see the car class in it because this is not accessible to anyone outside the package. A dot asterisk after the package name means that I want to import everything inside the package. Whatever is inside the package, just import it. Now, as I've imported the package, I will try to create an instance of car class. And as you know, the simple statement is type name followed by the variable name equals to new, again the type name. As you can see, it is showing an error right now. It says that the type car is not visible. The reason is that because we have created a class with default modifiers. So this is the very basic property of a default modifier. It is not accessible outside the class. So I have created these simple projects for you guys. I will share it once the class is done. This contains all the topics that we will discuss, and it will contain notes around different types of topics, different topics that we have today, and you can go through it. You can try to understand it more clearly. You can try to play around it with adding some methods or changing the access identifiers of different methods and variables and classes, and it will give you a more understanding of what we will discuss today. So after the default access modifier, we will move on to the next topic, which is the private modifier. Before I move on to the other topic, do we have anyone who has any question about default modifiers? All right. We will move on to the next topic, which is private modifiers. Now, this is something which we had discussed yesterday also. So when I say that I am declaring a variable which is private, it means that it is not accessible outside the scope of that variable. So and private is only applicable to variables and methods. You cannot declare a class as private, because if you declare a class as private, there is no point of declaring a class because it cannot be consumed by anyone. So only variables and methods can be private. And let me show you with an example. So I have created a small class called SUV car. I will take you there. Just a minute. Custom car. So I have created a small car called, yeah. So we have a small class called hatchback, and here you will see that we have all the variables declared as public. Now public means everything is accessible outside the bounds, to the people outside the scope of this class and outside the package as well. So if I try to create an instance of this class, let's say hatchback equals to my hatchback, which is again new instance, I will see that if I do my hatchback dot, I will see that all the inner variables, the member variables are visible to us, like engine size, has sunroof, and tire count. Now if I go back to the car, it says that these are the three variables which should be visible, and we are seeing these three variables. Now if I make a small modification here, and if I say that I have made tire count as private variable, now what will happen is that as soon as I change the declaration, as soon as I change the access modifier, you will see that I won't see that particular variable in the list of available variables. So all of a sudden I'm not able to use that variable. So tire count has become invisible to the outside world. Look, I don't see any any method with name tire count, right? So this is the basic concept of a private variable. uh, Mainly we use a private variable because we want to hide the inner working of a class. So there might be, so in this case, in a hatchback class case, as it is a very simple class, it doesn't make sense to hide the variables. But in complex classes, for example, I create a class remodeling a bank account, I would never want to display the amount of money inside that account. So I would not want to display that variable to the outside world. So I will create a control over that variable, and I will, after from through that control, I will make it visible to other people. So we will talk about that control thing later on, but this was the basic idea of a private access identifier. Any questions as of now? All right, so we will move on to the next topic, which is public modifiers. Yeah, so as we said, private is invisible to everyone outside the variable scope level. Similarly, public modifier is opposite of private. It is visible to everyone uh, outside of the bounds of the variable. So you can see that it can be applied to classes as well, and classes are most of the time declared as public because people would want to use those classes outside the package or outside the domain of that class. So I will give you a small example here. It is actually the same example that we had earlier. uh, we had a hatchback class, and in the class we had these three variables, and all of them are public. So, and I showed you that it was all the three variables are visible here. If I do a dot, you will see that engine size, has sunroof, and tire count, all these three variables are visible. So you, in any interview or probably while designing your classes, you will come in, you will face a problem where you will see that whether I should declare a variable as a private or a public. So you have to design your classes in such a way that accidentally you are not making anything which is critical to the class as a public variable, so that so that the consumer of your class might misuse it accidentally. So for example, you are trying to, in our car example, probably you try to expose the number of the tire count to the outside world as a public variable, but people or the consumer of the class might accidentally change it from 4 to 3, and the class state will change, and it's not possible to have a car with 3 tires. So it all depends on how you are designing your class, and based on that you can select any access modifier. So this was public access modifier. Then we have the protected modifier. So, well, this modifier is defined by the keyword protected, and this means that the variable is protected from, so let's say I have an example of this. Let me just pull out the example. Yeah, so I have created a car called custom car. This is the car, and you will see that in this car there is a mix of access identifiers. The class is public, then there is another variable tire count which is public, and then there is one which is private, and similarly we have another one which is automatic, which is a protected boolean variable. Now all the protected boolean variables are only visible to the subclasses. This means that if any other class tries to extend or inherit custom car, only that class will be able to see protected boolean is automatic. So I will show it to you with an example. So now I have created a variable of custom car in which we had this protected boolean variable, and you will see that if I do a custom dot, the variable name was is the variable name was is automatic, and you will see that I'm not able to access is automatic. It's not accessible to me. So it is not visible to anyone outside, anyone who's trying to use the car. But this variable will be visible in the class which is trying to inherit custom car. So I have created one more class which is custom subclass, and this class has inherited from custom car. So I will show it to you here. So you will see that I have created a public class called custom subclass which extends custom car. Now as it extends custom car, it has access to all the variables which are declared as public or protected inside custom car, and as a result it has access to our protected variable as well. So if I do is automatic, you will see that it is accessible here. So only those classes which inherit from custom car will be able to use its protected members. So for general purpose, protected members won't be visible to anyone else except the subclasses. Well, I think this was little confusing probably. So anyone, any questions on this one? This is a little complicated.
I have one question.
Yes.
Currently we see that the custom car which is extended by custom subclass, both of these classes belong to the same package, access modifier.
Yes.
And in that case you are trying to use the is automatic variable which is declared as protected.
Yes.
Suppose this particular class, that is custom subclass, belongs to some different package and still it extends the custom car class. Will this is automatic protected variable still be accessible here?
Yes, it will be accessible because we have just imported the complete class from a package. So if I let's say this package access modifier, it was something else, let's say XYZ package. So when I will try to use custom car, I will just put a statement here which would be import the package name of the custom car, and after that whatever way I use, it will follow the standard norms of Java. So after that, everything inside custom car will be visible to our custom subclass, which is the subclass. It will everything inside it which is public or protected will be visible. So it will just follow the same pattern.
Okay. If I have a method declared as protected, the same rule applies, correct?
Yeah, the same rule applies.
Okay. Now in case instead of protected, it was a default access specifier.
Yes.
Will the situation remain the same then?
So in case of a default access modifier, you won't be able to extend that that class because it won't be visible outside the package.
Okay.
So let's say let me show it to you with an example. Let's say I had a class called car and I changed it to a different modifier. Let's say a different package. Let's say XYZ, right? Now package, yeah, probably no, I have to show it the other way around. So I will show it to you after this class. Well, the answer is that it won't be accessible because outside the package the whole class won't be accessible. So there is no point in anybody trying to inherit that class because it is not even accessible.
Suppose a class is public, okay?
Yeah.
But a method inside that class is default. Then what?
So it won't be accessible because it is default.
No, but I'm extending that class, right?
So you are saying that I'm extending, yeah. So in that case, if you are extending the class, you will, so okay, but that is not a protected member. Yeah, it won't be accessible because it is at a default access modifier level.
No, but my one class, it is public. The second class is also public and it extends that particular earlier class. And I have a method which is defined as default or protected in my class 1. And the second class which is extending the first class, I'm trying to use the same method here. Will it let me do it because I'm extending the class?
Well, by principle, it shouldn't allow you to extend the default access modifier method. It will allow you to extend the protected member and the public member. So we can see that with an example later on after the class, where we will stay here for another 30 minutes. I will create a small example and we will just verify what happens in that case.
Okay, fine.
All right. Any more questions?
Well, this is Srinivas.
Yeah, hi Srini.
Hello, can you hear me?
Yes, I can hear you.
Just a very quick question. So you mean to say, in other words, when it's protected, this can be accessed only when it extends, right?
Yes.
Okay, that's it. That's it. I need to answer. Thanks.
Yes. All right. So anyone else? All right. So we will move to the next topic. Let me just put it up. Yeah. So after protected modifiers, we will talk about non-access modifiers. Now, non-access modifiers are again access modifiers. They are actually trying to give more meaning to whatever variable or a class you try to put these non-access modifiers. So we will first discuss about a static non-access modifier. The static keyword denotes that a member variable or a method can be accessed without requiring an instantiation of the class to which it belongs. It means that, let's say I have created a class, and in that class I have created a static member. Now static means that it will have only one instance, and the instance of that static member will be created when the program starts. So whenever a program starts, it first well, not the first thing, but after a few mandatory steps, it tries to create all the static members, all the static classes which are in the program, so that only one instance of those classes and variables exist in the program, and those variables are accessible throughout. You can use them, and you can simply just use it in your program. So let me show it with an example here. So I have created a simple static class, and in this class, well, there are a couple of key points in static non-access modifier. The first one is that, yeah, so let me just go with this example. Let me just make it little visible. Yes. So I have created a class called static sample. Now in this class, I have created one public integer, which is a simple variable, and then I have created a static variable, which is a static variable. Now you will see that first we will talk about what happens inside the class, then we will talk about what will happen outside the class when somebody tries to access it. So all the static members are visible to everyone inside the class. So if I create a public method called static sample, which is the constructor here, I can access both static and public member, static and a non-static member. You can see that in static sample I am able to assign value to a simple variable and the static variable as well. Similarly, if I create it was the constructor, if I create another method, I will be able to access the static variable. But when I create a static method, I won't be able to access the public or the non-static members of the class, because the reason is that, so let me try to access a non-static member, which is a simple variable. You will see that it throws an error which says cannot make a static reference to the non-static field. So the reason is that a non-static member is only instantiated when an instance of class is created, but a static member instance is created by default during the runtime. So if during while creation of these static instance, we try to access a non-static instance, we will end up in exception. That's why uh, Java runtime and the Java compiler makes it impossible for someone to access a non-static member inside a static method. So this was one thing which is very important around static members, static classes and variables. The other thing is that if I go to the program.java, here you can see that I can access static members without creating an instance of the class. So in our static class, let me close other classes first. So in our static sample, you would see that I have two static members. The first one is is called a static variable, and the other one is the static method. So if I try to access these methods without creating an instance of a class, I will be able to do that. So to access static members, all you need to do is just type in the name of the class followed by a dot, and after that you will be able to see all the static members. So a static variable and a static member is visible. I can easily access it, but I am not able to access the public members, non-static members inside the class. So you can see the non-static members are not visible here. Let me show it to you. Here I had a non-static member called a simple variable, which is not visible, right? So this is how we access static variables or static members of a class. Now to access, the class is static, but we can create an instance of the class also. So I have created I can create a simple instance stating that static sample a equals to new static sample, right? It is perfectly fine for me to create an instance of a class which has static variables and methods. Now you will see that when I do a dot, I am able to access the non-static member, but I'm not able to access the static part of it. So if it's right here, so if I try to access these members, it will be same as the value which was assigned during the start of the program, right? This is a bit confusing concept to understand. I think I will ask for any questions right now to clear up the concept. Any questions in understanding this?
Yes, I have a question.
Yes,
I would suggest if you go through it once again. I got a little bit confused.
all right. Arvind, you had a question?
Yes. So if I understand you correctly, only static class can access this static members, be it a method or a variable. If my class is non-static, then it won't be able to access either the static method or the static variable.
No, so there is nothing called a static class. A class can have static members and variables. So to access the static members and variables of a class, you don't have to create an instance of the class. You can directly use the name of the class followed by a dot, and after that you will see all the static methods. Now to access the non-static methods and variables of a class, you have to create an instance of the class.
Okay, so without creating instance, we can't directly access this.
Yeah, so without creating the instance, you cannot access non-static members. You can always access the static members.
Okay.
Okay, so as Laksh said, let me try to explain it again. So this is our class, which is a simple class. You can say that I haven't used static keyword here. It is a simple class. Probably we are not even able to allow, we are not able to use static keyword in classes because I think it's not allowed in Java. Now in this class I have two member variables. The first one is public int a simple variable, and the other one is a static variable. And after that, I have two methods. The first one is a non-static method and the other one is a static method. You will see that this is a static method and this is non-static method. Now, the meaning static means that there is only one instance of this method and the static variable above. This means that throughout your program, whenever you will run your program, there will be only one instance of it. So any changes made to this variable will always reflect in any call made to this variable from within your program, right? Now it's not the case with non-static members. Non-static members are tied to a class, so I cannot access a non-static member without creating the instance of a class, right? If I don't create an instance of static sample, I won't be able to access a simple variable. But in case of static, without even creating an instance of this class, I will be able to access this variable and I will be able to access this method, the static method. The reason is that when you run your program, the Java runtime finds out all the static methods and classes, all the static methods and variables, and creates an instance of those methods and variables. Now those instances are unique throughout your program. So anyone trying to access those static methods will always end up using the same static method. So in a way, this method is static. You cannot change it. You can change the value of the variable, but you cannot create another instance of it. Does it simplify it, or you want me to write a small piece of code to show it to you?
No, it's fine. I understood, but it again created one more problem, one more doubt.
Yeah.
Now what I'm thinking is, suppose there is a different package, which calls this static sample.java.
Yes.
And we have a static variable declared inside static sample.java.
Yes.
Now in the other package, I can simply, if I have imported the current package, so in the other package, I can simply call static sample.java and play around with the static variables. So in that case, it becomes vulnerable.
Yes, it does become vulnerable. And your point is correct that it becomes vulnerable. But the main concept of static method or member is that it shouldn't. So you will always have static methods only in cases where you know that there is no state to store. For example, math is a math class in Java. It gives you a couple of static methods. For example, a add method, math.add. So this method doesn't save the state. So whatever variables you pass in to that method, it simply sums those variables and returns the value to you. So in that case, there is no vulnerability, no vulnerable state associated with that. You cannot change anything inside the math.add method because it doesn't have any state.
Okay.
So you will always create a static method when you know that there is no state to maintain. For example, in this case we have declared a static integer, but the normal practice should be a static integer should be like, for example, a constant value which you will use throughout your session, which is not supposed to change. So in that case you will make it static and you will put a final keyword. The reason is that you will make it in such a way that it is not changeable. So you will create only those variables or methods static which you know that won't change throughout the program. For example, in math class you will find the speed of light as a static variable because it doesn't change, so nobody would be changing it. So that is the reason, like, you have static variables. So it reduces the burden of creating an instance when someone tries to use it.
One more doubt. When you have declared that variable, you have put a public keyword just before static.
Yes.
So will it always be the same, or it can be private also?
So I will show it to you. If I do a private static int, you will see that in here I am not able to access it. So it defeats the purpose of being a static variable.
Mm-hmm.
So
Yes.
you have created a static variable so that everyone can access it and the value of it never changes. But
Right.
if you put private, it will defeat the purpose of it.
Right. I understood.
All right. Any questions around this?
So again, as we are taking the example of our car class,
How do
so
we?
yeah, Snail, yeah, please go ahead.
Yeah, my question is like, how do I know whether I need to declare a particular member variable or a method as static? What is the whole purpose of marking that particular method or variable as static? Because while writing or designing any kind of framework, what makes me think, or what is the thought process of keeping a particular variable or method as static?
All right.
So that's what my question was, Viren. So as we are taking the example of car, so would you be able to give us the example, like what sort of variables you would declare as static and what sort of method you would declare as static method in this car class?
All right. Yeah, sure. So let me take the example of frameworks that we create. So in a framework, you will always have a class which will log your steps, right? A logger class, which you will use to log different values or different things in your test. Now there will be multiple tests. At times there will be like 2000 tests that you would want to run. Now you would create a logger for every test, because every time you do something like this, for example, custom car, right now it is a custom car. Let's say you create a logger instance, logger, a new logger, right? This statement has a memory implication, plus it has a time associated with it. Now you wouldn't create a logger class every time. So what you will do, you will create a static logger class. Now this static logger class will be shared among all the tests, right? So all the tests will share the same logger class, and it will remove the burden of creating a new logger every time and passing it to your tests. All the test, the only thing the test needs to do is just call the logger class and write down the comments. Is it clear?
Still, I would say, like, if you were able to give us the example of car class, like, we would be able to make sense of it then.
Okay. Okay.
And first of all, can we have a static class? Because sometime back you mentioned that in Java we don't have static classes.
Yes. So whenever I say that I have created a static member in a class or a static variable in a class, the normal terminology is that the class becomes static. So it is not like a class is static, but yes, we call it that it is a static class because it has some static members available in it. But doing this public static class, this will always give you an error. So syntactically, it is wrong to say that a class is static, but in theory you always do that.
Because what I have read somewhere is that if you have nested classes, then the nested class can.
I'm sorry, Snehal, your voice just broke.
I mentioned that I read it somewhere that if you have nested classes, okay, the nested class can be declared as static.
So okay, so nested class, what will be a nested class? Nested class is just a variable inside a class, right? And you can always declare a variable as a static, right? But in a template you cannot say that this class will always be static.
Okay, so that outer class will never be static, but the
Yes.
inner class can be
Yes.
static because it's nothing but a member of the outer class.
Yes.
Okay.
All right. So, well, I think there is some confusion around the static part, and I understand because static is actually a confusing topic in Java. Uh, at times, we don't understand when to make a class static and when not to make a class static. And I would suggest that, and one thing is quite clear that this comes with experience. While you create more softwares, you learn that there are a couple of things which we can create as static and there are other things which we cannot create as statics, and this is how you learn about it. So the basic idea of it is, if the basic idea is not clear about the static class, I will again explain it, but if the basic idea is clear, let us move ahead and let us wait for the framework session where you will actually understand why a logger class is a static class. And that is the time when you will understand that, yeah, making a logger class as a static makes more sense. Is that fine, Laksh? Snehal?
Yeah, that should be fine.
All right. So, yeah.
Yeah, perfect.
I'm sorry, someone was asking
One
a
more
question.
small question.
Yeah. Yes, Snehal, go ahead.
What is a static block? Because I guess static block is also a concept in Java.
Yes. So a block is nothing but when you do this. It is an anonymous block. You will have a piece of code in here that will execute perfectly fine, but it is anonymous. The reason we use a static block is that you don't have to worry about the variable scope. You know that whatever you are creating inside it will be destroyed after that. Similarly, we have static blocks which we pass on to functions. So that is a very advanced concept in Java. Probably you might not even need it here. And if you still want to get around that, I will suggest it we take it after the class, because it might confuse the people who are just learning Java right now.
Okay, okay, fine.
All right. All right. So I think Mark or Brian, someone was asking a question.
Just want to agree with what you have said before. We
Yes.
can discuss it during the framework.
Yes. Yes. That,
And then, yeah, the concept is clear for me, and I think it's fine.
all right. All right. So without wasting any time,
Hi.
yeah.
Sorry.
Yeah.
Sorry.
Yes, Brian.
Can you just return a second to the concept of sorry. Yes, to the static members, please.
This one, right?
Yes.
Okay. So in this class, we have declared a static variable called, it's an integer variable, and the name is a static var. Now,
Yeah.
the point with the static variable is that it is not necessary for you to create an instance of this class in order to access this variable, static variable. So let me show it here. So this was our static class and the static variable was a static var, right? So all I have to do is just do a static sample, which is the name of the class, without even creating an instance of it. All I have to do is just do a static sample dot, and I will be able to see the static variable, right? I will be
Yes.
I will be able to access it. If it is a private, if it is not a final variable, I will be able to assign values to it, right?
Okay. What about the static method?
Same goes with the static method. So it will be accessible to you without even creating an instance of the class. I will do static sample dot the method name.
Ah, okay. Okay.
All right. So this
All
is what is static classes, what static methods and static variables are. We will discuss more about it while designing our frameworks, because that is when the real need of it will come. So this is right now this is just a theory, and it might probably confuse you. Let me move on to the next one, which is the final non-access modifier. Now, the purpose of a final non-access modifier is to make sure that nobody, so when it is a class, then it is to make sure that nobody is able to inherit the class. And when it is a variable, it means that nobody is able to change the value of the variable. And when it is a method, when we declare a method as final, it means that nobody should be able to override the method. Now, overriding is another concept in programming, Java programming, where we change the behavior of a method based on the subclasses. We will talk about that in the coming slides. So overriding is just changing the way the method behaves. Now, if I say that a method is final, it will mean that nobody else would be able to, nobody else in the sense like any class which is trying to inherit this class won't be able to make changes to the final methods. Let us talk about it. Let us try to understand it better. Yeah, so I have created a finalized class. This is a simple class. So what I have done, I have marked this class as final, right? So this means that it won't be able, nobody will be able to extend this class. So let me show it to you with an example. So this is the class, finalized class, and it is in package 2. All I will do is I will ask some class to extend, try to extend it. So just let us take an example of custom subclass. I will ask it to extend my finalized class. So you will see that as soon as I try to extend it, I get an error. Now what is this error? So this is a very important feature in Eclipse. All you have to do is just hover the mouse over the these red lines, and it will give you the reason, and it will give you possible fixes to it. So it clearly says that finalized class cannot be resolved to a type. Well, sorry, I gave you a wrong example because these two are not even in the same package. I will take an example of abstract class. No, abstract class cannot. Yeah. So here, are we in the same class? Not an abstract class. Let's say I have a static sample. So I think I have opened too many classes. Let me just remove one. So what I meant was this was our finalized class, and I have declared it as final. Now if I ask some other class to extend it, extend finalize, extend finalized class, it will throw an error. It will say the type static sample cannot subclass the final class and then the class name finalized class. So it also says that to get rid of this error, you have to remove the final modifier of finalized class. So it simply means that static sample, which is this class, cannot extend this class finalized class because it has a final access modifier around it. So this means that this class is not extendable. We make a class final class because we don't want to change the implementation of a class. We don't want anyone to make changes to the way this class behaves. So in our probably in our Selenium project, we might not require it, but in complex projects where the implementation plays a critical role, people would always want to have their classes as sacrosanct. They don't want it to change. They don't want anyone to re-implement the class by inheriting the class. That is the reason why we use final. Now, the final keyword in a variable definition plays another important role. It says that the final, whatever variable is declared as final, is not changeable. Now it comes into it becomes really important. Let me fix this one first. Yeah, so it becomes, here we have declared a variable called variable integer, which is static plus it is final. Now I can do this also. I can remove it from the final list, from the static list, and it will work fine. But right now putting a static, it will solve two purposes. So the reason I have put it as final is that I don't want this variable to change. I will give you an example of critical calculations where you would want to declare some variable as final. Let's say you are creating an application which deals with income tax of the people. Now you will see that if you come in a particular slab, there is a percentage deduction. Let's say it is X percentage when you fall in this slab. Now that variable which will store the percentage of deduction for a particular slab will become final variable, because you don't want anyone to accidentally change it in the program. As soon as someone accidentally changes it, it becomes vulnerable. It actually produces wrong calculation in your system. So that is a possible bug. It is a bug actually. So that's why you will make it as a final variable. Now extending the same example. So why would I make that variable, which is the percentage of deduction for a particular slab in income tax, why would I make that variable a static? I would make that variable a static because I want everyone to access it. I want every calculation to know that for this slab there is this much percentage of deduction, right? And if I don't make it static, in order to get the amount of deduction for a particular slab, everyone would have to create an instance of the variable, instance of the class in which the variable is, and then will access it. This is an overhead for everyone. And let's say there are 10 classes which are trying to access, trying to get the percentage deduction in a particular slab. Then if it is not a static class, a static variable, everyone will create 10 different instances of it, right? Which is not necessary. Every instance will cost something in the memory. So in order to avoid those memory overheads and time required to initialize a class, we make it a static class so that when the program starts, an instance of it is created and everyone can use the same instance. I hope this clears the doubt around final.
I have a doubt, Viren.
Yes.
So, if I do not declare this a final integer as final,
Yes.
so I just declare it as public static int a final integer.
Yes.
And so, in that case, like in other class, would I be able to like change it?
Yes,
This
you
variable?
will be. Yes, you will be. So it is a public variable. It is
Okay.
subjected to change. Had you done it something like, so I will come to that concept also, encapsulation. So right now, yes, it will change. Anyone can change it right now. But if I don't want anyone to change it, I will put final.
Yeah, that's answer my question.
All right. Any more questions around this concept?
Hey Virendra, I have a question.
Yes.
Let's say if I declare my class as final,
Yes.
and is it a conclusion that the variables that are available inside my final class are also final?
No.
Or should I exclusively declare my variables as final?
So the answer to it is no. If you declare a class as final, it doesn't mean that all the variables inside it are final. The reason is that final to a class has a different meaning than what final to a variable has. So final to a class means that this class is not inheritable. Nobody can inherit it. But people can create instances of it and can change the state, which is these variables of it. So you got my point, right?
Yes, I did.
Yeah. So
if a class becomes final, I can't inherit it. But however, my variables, people can actually create instances for the class and use the variables.
Yes, you are right.
Okay. All right. Yeah, that answers.
All right. Any more questions? All right. So we will move along to the next topic. So don't worry if you're not able to get the concepts right now. I will share the same project to you with you guys, and you will see that I have commented out sections and I have put some exercises also in between. Just go through it, just run through it, try to debug it, and you will find like what everything means. So right now it's all theory and a little bit of code. So probably you might feel that, yeah, it's not, I'm not able to understand it. But yeah, once you see the code, it will be all clear in your head. And just in case if you have more questions after that, let me know. We can take it up in the next class. All right, so let's move on to the next topic. Before that, let me mute everyone. All right, so let us move on to the next topic, which is abstract non-access modifier. So there is one more important thing in any object-oriented programming, which is abstract. So whenever I say a class is an abstract class, it means that this class has just declarations. It doesn't have any implementation. And it also means that nobody can create an instance of an abstract class. So if someone tries to create an any instance of an abstract class, he will get an error. The reason is that abstract class doesn't contain any any implementation. So even if a user is able to create an instance of the class, there is no point in having no point in having that instance, because there is no implementation in it. So the syntax is abstract class, my class, and then the for the method we can use abstract void my method. Now when abstract applies to my any method, it means that that method should be overridden. It is a must for the class which is inheriting this class to override the method, to provide the implementation of the method. So these are like designing concepts. These are designing concepts, and they come into picture when you try to design your systems and you try to create contractual obligations between classes. So I will show it to you. This is an abstract class, and you will see that in this I have created an abstract method, which is abstraction method. Now then there is another method which is not an abstract method. So in this abstract class we can create a non-abstract method which will have some implementation, but all the abstract methods will not have any implementation. Similarly, this class cannot have an instance. Someone has to inherit it to create an instance of it. So probably I will show you an example here. Yeah. So what I was trying to tell you is that nobody can create an instance of an abstract class. So if you see it here, as soon as I try to create the instance of an abstract class, which is this one, abstract class, as soon as I try to create it, it shows me, well, it doesn't show me the right error because there was a problem. Yeah, as soon as I fix the syntax error, it says that abstract class cannot be, okay. Just give me a minute. I think we haven't imported the package. We are in package 2 only. Yeah, that's right. So it gave me an error stating that it is not able to resolve the package, resolve the variable. The reason is that as it is abstract, it is not, nobody can create an instance of it. So it is not available for anyone to be instantiated. So this is the difference when we create an abstract class as compared to a regular class. Now the inheritance part of it. Now abstract class should be inherited. We will cover it in the inheritance example. So do we have any question on the abstract class right now?
Yes, I have. I have one question. You told that in the abstract class, the abstract methods will not have any implementation.
Yes.
So if it's not serving any purpose, then why do we want to keep methods?
Yes. So as I told you, these are obligations. These are contracts. So abstraction is a way to create contracts so that we can make other classes follow it. For example, I can create a simple car class, and I can say that every car should have a function to start the car, right? So let's say it were a, let me add it right now. Before that, I will show it to you with an example. Let me just remove this first, and I will let me create a quick car class. So if we were to design cars in an object-oriented way, we would have to create a base class, right? So let's say car is the base class. Now in the base class there would be common functionalities. So I would say that this is a abstract class, and I would say that I want every car, everyone who creates a car, a new car, I want them to inherit the base class, and I want them to provide everyone with a method called start engine, right? So I will say I will create a base class, and I will make it a mandate for everyone who's creating a new car. Let's say from the base car class, anyone is trying to create a SUV class or a sedan class, class car, then he should be able to provide me a method which is start engine. Now every class will have a different way of starting an engine. For example, some classes has keys, some cars have keys. You have to switch on the key to start a class. Then the other classes have buttons, so you push a button and you start a car. So by stating that it is a abstract method, I am making it a mandate for other subclasses to give their implementation of start engine. Are you getting my point?
Yes, I am, but ultimately other classes will not be able to use the instance of it. If I try to create the instance of this abstract class, they will not be able to make use of that, right?
Yes, yes. So yes, so by creating abstract class, the reason is that you don't want anyone to create an instance of it, but you want every subclass of it, all the other classes like a SUV car, to have an instance, right? So SUV car is inheriting this car, this abstract class, and it is always providing a method called start engine. So this way I have made it a mandate for all the higher implementations of a car, for example a SUV car or a hatchback car, to have this method in them. Does it make sense?
Yeah, now I understand.
If you can show us with the example, like
Yes.
just go to any SUV car and just inherit this.
Okay, so before going there, I will just try to do it in this package only. Let me close every other class. Okay, so we just created an abstract car class. Now so while designing, I thought that there are some functionalities in a car which are common to all the cars. So what I do, I create a base class and I make it an abstract class, and I put all those functionalities in that class. For example, there would be one way to open the doors of a car, let's say. Open doors. Some sports car have you know doors which open upwards, then other have which you have to pull out. So this way I know that every car will have doors and they will open, but I don't know how they will open. And similarly every car will have a start engine functionality, but I won't know that it may be possible that all cars have a different way to start the engine. So what I will do, I will create a small abstract class. I will put all those common functionalities in there, and then I will ask all other implementers of cars. For example, someone comes up with a new car and says that this is my customs car, right? So I will ask it that if you are creating a custom car, you have to extend the car class, and when you extend the car class, yeah, so when you extend the car class, it will make it mandatory for you to implement start engine and open doors. Now if I remove it, you know, as soon as I say that I won't implement the methods given to me by car class, it will throw an error. It will say you haven't implemented the abstract methods and you are bound to implement it. So by this I have created a protocol. I have said that every car manufacturer has to give me the way to start an engine. Let's say this car starts by inserting the key, right? And the doors open, like you have to pull the doors to open, right? So you will implement your functionality here based on the custom car. And similarly, let's say another vendor of a car comes in and he says that I have a car which is a sports car, right? And he says that I will also implement car. I will also implement car, and I will make it mandatory for him to give me his implementation of starting an engine. So probably the sports car starts in a different way. Let's say for a sports car to start, they have to first press the clutch and then they have to do a push of start button, right? So they will implement their method, their way of starting engine here, and similarly they will say that my sports car doesn't have a door, right? We don't need doors. We just jump into the car and we come out of the car, right? So this is how I have made every car to follow a pattern. I have made every car to have a start engine and open door functionality, and this is how every car can have the same functionality but a different implementation of it. Am I clear?
Yes. Thank you so much.
Yeah. So and
Yeah, but I don't want a sports car.
You don't want a sports car, okay? So now this, as I have explained this concept, this is called polymorphism. Now why is it called polymorphism? Because it can show different behavior when it is in different classes. So a sports class, the start engine method shows a different behavior. It says that first press clutch and then press the start button. And similarly the open doors says that I don't even have doors. But when I go to custom car, the same method, which is the start engine and open door, it has different implementation. So start engine says that I will start if you insert the key, and the open door says that you have to pull the doors in order to open the doors. So this is called polymorphism. We have just covered one topic from our coming slides. Any questions on this one till now?
Yeah, I have one or two questions.
Yes.
First thing is, like in an abstract class, can I have non-abstract methods which I can define?
Yes, you can. So in our abstract class, you can you can very well do a public void honk horns. You can do this, and you can say that the implementation is, just a minute. Yeah, you can say the implementation is press the honk button. And yeah, you can very well do this. Now I will explain to you the reason also, but does it answer your question?
It answers, yeah, but can I, do I also need to override this method in
No.
my subclass?
No, you don't have to.
Okay. So only the abstract methods I need to override, not the
Yes.
non-abstract methods.
Yes.
Okay.
Now the important part is, why would someone even have a non-abstract method inside the abstract class? The reason is that we cannot create an instance of a abstract class. Then why do we need a method which has an implementation which is non-abstract? The reason is that there are some properties and behaviors of system which are common all across the inherited versions. For example, all cars will have a way to honk horns, and let's assume for this example that all the cars have one way to press the horn button. Just press the horn button on the steering and it will honk. Be it a sports car, be it a custom car, be it a SUV, the only way to honk horn is to press the button on the steering. So in that case, as you know that the implementation is same, you know that it will always have to be press the honk button. The implementation is this. Then why would you want to have multiple implementations? So I would not want honk horns to be in every class. I would want that whenever someone from custom car calls honks horn, it is redirected to the base class, and it just executes the implementation here. This way we have increased the reusability of code, and we have just concentrated the code at one place. This is how we create modular applications. Does it answer? Does it explains the concept clearly? All right. Any questions on this one? All right. Laksh, am I audible to everyone?
Hello?
Yeah, am I audible to everyone?
Yes, yes.
Yeah. All right. So assuming...
Yeah, Virendra, I had a question.
Yeah.
You said that abstract classes you cannot create instance. So
Yes.
can we conclude that abstract classes are always static classes?
No. So a static class, okay. So whenever you have a class which has static methods, which for the sake of simplicity we are saying that a class is static. So with the static class, what happens is that one default instance is created every time the program starts. Right? So it has an existence in the memory when the program starts. But for an abstract class, there is never an instance which is created. All we always have is a template. Now, whenever this class is inherited by a new class, then a new class instance is created. The instance of a new class is created, not the abstract class.
Okay, so the honk-ons method that we created in my car.java file,
Yes.
the class, how can I use that in any of my other subclasses, the customs car or sports car?
So whenever someone says, whenever someone like this says that public class customer car extends car, right? Whenever someone says this, it means that the functionality has been imported inside this class. So you will see that the functionality is imported. Now, as soon as it is imported, there is no need for having an instance of the abstract class. So it's like you don't need abstract class to utilize this functionality. It is being imported directly here.
And I see that, right, and I see that you're using a this dot honk cons.
Yeah.
So that keyword this can be used under this situation also, where I'm doing a where I'm trying to use a subclass method in a superclass. That time also I can use a this.
Yeah, you can use this anywhere. So if I write this in, so this means whatever context I am inside. So it gives me all the attributes in that context. So if I write this in program.java, it will start giving me the context of that place. Well, it is not allowed in main. Yeah, please go ahead.
That's right, because you have extended your car to your customs car. That's the reason the method that is available under car can be accessed in custom car by using this keyword.
Yes, yes, exactly.
Okay, it's because of inheritance.
Yeah, it is because of inheritance, exactly.
Okay, all right.
On the same lines, we also have a super keyword, right? So I can also use a super keyword and call the method honk-ons. Is that correct?
Well, yes. Can we discuss it in the coming slides? Because in the coming slides, we are about to discuss the same thing.
Okay.
All right.
Fine.
All right. So moving ahead, let me take you to the next thing, which is, so we were discussing about abstract. Now we have gone past the modifiers. Now let us talk about the basic operations that are provided to us in Java. And these operations are very basic. And I hope probably almost everyone is clear with these fundamentals, so I will try to move ahead as quickly as possible. So these basic operations are addition, subtraction, multiplication, and division. So addition is used to add two numbers, subtraction is used to subtract two numbers, multiplication is used to multiply two numbers, division to divide two numbers. Now similarly we have different relation operators, which is equality, non-equal to, greater than, less than, greater than, equal to, less than, equal to, and the and operator and the or operator. So let me take you to the example here which I have created. Conditional conditions and loops. Yep. So this is one straight program. We don't have classes in this because you don't need classes to explain this. So is my voice breaking? Is everyone able to hear it properly?
Yes, I'm able to hear you clearly.
Fine with me.
All right. All right. I think Srini is facing some problems. Probably it will work. So as we were talking about different mathematical operations that are available to us, the first one is the addition operator, which is represented by the plus sign. And here is a simple sample where I have created an integer called sum, and I have created two other integers which have some value, which is like 30 and 40. And when I do sum equals to a plus b, the sum, the total sum of these two numbers is put into the other the sum variable. Now we can print it out and it will show what the sum is. Similarly, we have subtraction, which subtracts two numbers, and then we have multiplication, which multiplies two numbers and is represented by an asterisk. Subtraction is represented by minus sign. Similarly, we have the division operator. The division operator is to divide two numbers, and it is represented by a slash. This is the slash that I'm talking about, and it divides the two numbers. Now let us go into relational operators. Now relation operators are present in Java, and it gives you a way to provide equality, to find out whether something is bigger than the other, or smaller than the other, or equal to other. Now the very first operator, which is very important, is equal to operator. Now before we go into equal to operator, I would like to talk about a conditional statement, a condition statement, which is if. Now if is like the English if. It says if something is true, do this or do something else. So now when I say, so the syntax of if is if, then we have these brackets and the condition inside it. The condition has to be a Boolean condition in order for if to work, and after that whatever code we want to execute. Now it says if A equals to B. This is the equality operator. What it will do, it will get the value of A, it will get the value of B, and it will compare it. If it finds that both the values are same, let's say A is 40 and B is 40, it will say that yes, both the values are same, and it will return a true value. Now if statement, it will say that yes, both the variables are same, and I will execute this part of the code. So this is how if statement works. Now after that there is another operator which is called not equals to. Let's say you want to find out whether A is not equal to B. So all you can do is exclamation mark equals to, this is the operator. All you have to do is on the left hand side put the variable which you want to compare to the one on the right hand side. If these two variables are not same, it will say, it will return a true, and it will try to execute this part of the code. Once it executes this part of the code, it comes out of it and it moves on to the next line. Now let's say you want to check whether whether one number is greater than the other number. So in that case we have the greater than operator, which is represented by the right angle bracket, and it says whether the operand on the left hand side, which is A, is greater than the operand on the right hand side. So if it says that yes, A is greater than B, it returns true, and the code in this block is executed. So if A greater than B, yes, then this will be executed. Else it will just skip it and it will move to this point. Yeah, so moving on to the next operand, which is less than operand. In this case, it is just opposite of the greater than operand. It verifies whether the operand on the left hand side, which is A, is less than the operand on the right hand side. If it finds that yes, it is less than the operand on the right hand side, it will execute this statement. Else it will execute this part of the code. It will skip this part of the code. After that, there is another operator which says whether the operand on the left hand side is greater or equals to the operand on the right hand side. So this is represented by the right angle bracket followed by a equal to sign, and as you can see, this is the condition. So it will verify whether A is greater or equals to B. So let's say if A is 14 and B is also 14, then this will pass. And let's say A is 14 and B is 13. So this will fail because it wants A to be greater than or equal to B, at least be equal to B or be greater than B. So if it is true, it will move forward and execute this block. If it isn't, it will come out of it. Now similarly, we have less than equal to, which is represented by this, and it is almost similar to what we have in greater than equals to, but this time it just verifies whether the left hand operand is at least equal to the right hand operand or less than the right hand operand. So if it is true, it will execute the if block, else it will move out. Now there is one more type of if statement. So till now what we have discussed is that whenever the condition is true, execute this, right? But this is just one code path. This is just one branch, right? If this is true, execute this. Now we might also come into a situation where we have multiple paths that we want to execute based on a condition. Let's say let's say when the left hand operand value is 5, I want to execute something, and when the value is 6, I want to execute something else, and when the value is 7, I want to execute something altogether different from the above two options. In that case, we have the if else and if else if these two. So the if else gives you two code paths. It says that if A is greater than B, I will execute this. Otherwise, I will move into this block and I will execute this part of the code. So we have two code paths. If A is greater than B, execute this, else execute this. Similarly, we can have multiple code paths based on some condition. In this case, it says that if the value of A is less than 10 and greater than 0, means the value lies between 0 and 10, I want to execute this. Otherwise, if the value of A is less than 20 and greater than 11, which is represented by this, I want to follow this statement. Now there is one operator which is double AND sign. This means the binary AND operator. This means both these conditions have to be true in order for this statement to be executed. If any one of these two conditions is a false, it will not execute this statement, right? So it will check whether A is between 10 and 0. It will execute this, else it will move on to this statement. It will verify the condition again. It will say whether A is less than 20 and greater than 11. If it is true, it will go inside it, else this is the default statement. If none of the above conditions, two conditions are true, it will execute this. Now this was the if else statement. Now I can show it to you by running it, but it won't make sense because it is quite easy and anyone who will read it will understand it. So I will just skip that part and I will move on to the next operator, which is the OR operator. Now OR operator is the binary OR operator. It means that unlike in the AND operator where both the conditions had to be true. Mark, am I breaking on your side? I think some people are facing some voice quality problem. Am I audible to other people? Laksh, am I audible to you?
Yes, loud and clear.
All right. All right. So I think it's a temporary problem. So I was talking about the OR operator. So unlike AND operator, where it is required that all the conditions are true, in OR operator, it's the other way around. So it says that if any of the condition is true. So this is the OR operator, and the condition on the left and the right side are the two conditions. If any of the conditions from the left or the right side is true, this will move ahead and will execute the statement inside the if block. Else, if none of the conditions are true, it will go and execute the else block. Now it was quite quick, so before I move to the next topic, I will ask if anyone has any question around this. All right, no question. I will share this code, so probably you can just loop in through using your debug mode. It will make you more familiar with debugging, plus it will give you the understanding of what the if and other operators are. So now we will discuss another important part of
So,
yeah.
sorry to interrupt you. So, if you can just show us the one example, like how to debug and how to go through this statement one by one.
All right.
So just one example. Yeah.
All right, sure. So, all right. So debugging, yes, debugging is a very important tool at our hands, in our hands, which helps us learn more about our code and the code path it follows. So in Java, in Eclipse, this is your code window. On the left hand side, you will see this blue bar, right? So all you have to do is just double click in front of the any of the statement, double click on this blue bar, and you will see that a breakpoint is applied. Now a breakpoint is a point where your program will break into when you run it in debug mode. So it is in sequential order. So the breakpoint which comes first will be hit first, and your program will pause at that moment. And while it pauses there, you can query quite a few properties of your program, and you can understand what is happening. It's a really nice tool to debug. Now there are two modes to run Eclipse. One is the run mode and the other one is the debug mode. In run mode, Eclipse will ignore all your breakpoints and execute the program. So in that case, you won't be able to debug. In a debug mode, your Eclipse will try to find the first breakpoint and break into that. So the shortcut is F11. I won't use the shortcut because I want you to see what I'm doing. So I will just do debug, and you will see that it will start. It has moved me into the debug perspective. It starts and it breaks into this statement. As you can see that there is an arrow now. This arrow shows that this is the point where our program is right now. Now, when in this point, you can query any variable you want. You can just put your mouse over that variable and it will show you the variable, the value inside the variable. So right now sum has value 0, and similarly A has value 30. Now I have moved to this statement. In this statement, what I can do, I want to just move one step ahead, right? So I will do run and I will do step over. Step over means it won't go into the details of this addition, it will just step over it. So it steps over it, and now we can see that the sum has a value 40, which is 30 plus 40, right? Similarly, I can move along one by one, and I will see that it has just executed the system.out.println statement, and as soon as it does that, it prints the value which we want to print into the console. You can see that it has just printed the sum of A and B is 70. Look, this is what I wanted it to print, so it will print that. Similarly, we can just step over all these methods. I will break here at the if block so that I can explain you what if block is. I will move ahead, and here when I move ahead, it reaches to the next breakpoint, and here it stops at the if statement. At the if statement, you can see that this is the logical calculation. Here it will calculate whether the condition is true or not, and this is the condition. Now you can see that A has a value 40 and B has a value 40, right? So this means, and the operator is equality operator, this means that the condition is true. So what it will do, it will move into this statement. It will try to execute this statement. So I will just do a step over and you will see that it has just moved on to this statement, right? So this is how you can just debug through. I will move to the next one, which is the next if block. I just wanted to show you how the if condition skips a block. So now it moves on to the next condition.
Do we have a? Yeah,
I'm sorry.
I have a question.
Yeah, Arvind, you had a question?
Yeah, do we have a separate watch window where we can see the value of all the variables?
Yes, you have a watch window. So this is one more perspective that you can look into. Go here and show view, and here you will see a watch window. Search for it. Oh, that's a view. I'm sorry. So window, open perspective, other. Well, I cannot find the watch because it is here. Do we have it here? Well, I think I have misplaced the watch window somewhere, so I won't be able to.
I think if you go to default perspective, it will give you the watch window. Otherwise, like if you double click
Okay.
on the variable and right click,
Yeah.
it will give
Yeah.
you watch. Yeah.
So here in the, well, it would be quite quick for other people. So I don't know. Yeah, actually I had made some changes to my my Eclipse, and I think I've lost it somewhere. Watch. Yeah, so there is another window called watch window.
No, just
Double click where?
double click on the variable and then right click on the variable.
Okay, you want me to add it to watch. Okay, so what
Yeah.
you can do, you can monitor the variable property in a window, which is the watch window, and it should be somewhere here. Well, there are lots of windows. Watch, yeah. So you can do this, and it will.
It's there. Watch is there.
Yeah. This is the expression watch window. Actually, I don't use the watch window much. That's why I haven't it here. I don't have it here. So you will see that you have the variable right in front of you, and it will continuously display the value of the variable. Let me go back to the debug mode. And I'm sorry, I don't want to break the flow. That's why I'm not going into the watch window right now. So you can add the watch window and you can see all the variables there, or you can hover over it. So I want to show that how the if condition skips a block. So let's say now we have reached this point, and we will see that A and B are both true. So let me change the value of B. You can change the value of any variable right here. Let's say, why is it not letting me change it? Okay, so let me add it to watch, and in the watch window I can change it. Okay, yeah, here, yeah, I will change it to 8. This is how Java does it. Let me see. No, okay, so actually it's not, I'm not able to change it right now. I have made some really bad changes into my program view. Yeah, this is the window that we were talking about. Yeah, so yeah, here I can change the value at the runtime. We have a separate class about debugging in the coming sessions, and it will explain everything about this. That's why I'm not picking it up right now. So I have changed the value at runtime of B. So it will oh sorry, it was a not equals to. So I have to change it back, sorry for that. So this is the not equals to operator. So A is 40, B is 40, and it is a not equal to operator. So this will return true only if A and B are not equal. So if A and B are not equal, it will go into this loop, this statement, otherwise it will come out of it. So we just want to see what happens. I will step over it and you will see that uh, it has skipped the if condition statement. It has skipped this part. So this is how the if block works. If the condition here is not true, it will skip this part and move ahead. If the condition is true, it will execute this part. Now coming back to the watch window, this is the watch window, the variables window, where you will see the list of all the variables that are in your program, and you can edit them at runtime. Just to check all the code paths, you can edit them at runtime and it will be reflected in your program. So we will talk about this in our debugging classes, where we will teach you more about debugging. I hope you are clear with how the if statement works, and once you get the program, you can just run through it using similar techniques like I showed right now, and you will be able to understand how it works. Do you need more explanation on this, because it was quite a basic stuff?
No, it's fine.
All right, so I will move ahead. We have just covered the basic operators and the decision making part. We have also covered the if else block. Then we have covered the if else statement. Now let's go to the while loops. Now looping is a very important construct in any programming language. It allows you to execute same statement multiple of times, or execute the statement until a particular condition is reached. So a typical while loop, there are variations of while loop also, but I will put it as a tasks for you to do at home. So a typical while loop has a syntax like this. So it will start with while, and inside the brackets you have to provide the condition, and after that in the curly braces you have to provide the statements that you want to execute till the time condition is true, right? So I have created a simple while loop where I have declared a variable x, and this variable I have initialized it with the value 0, and after that I say that while the value of x is less than or equals to 20, I want to execute these two statements, because these two statements fall in these two curly braces. These two statements will be executed till the time this condition is true, right? So what will happen is that code will reach here. Let me just debug it and show it to you. Yeah, let me debug it. And it reaches the first breakpoint, it reaches the second one, and it reaches the third one, and yes, it reaches the fourth one. I will change perspective, and here we are. So we see that the statement right now the program is at this point, and it executes the first statement, which is
Viren, is your window frozen by any chance?
no, it's not frozen. Are you not able to see it?
Yeah, the debugging stuff, I'm not.
All right.
It's working fine for me. If anybody else,
anybody else facing the same problem?
My screen,
it's clear for
your
me.
screen also stuck on my screen.
I think it was marked.
Yeah.
It just happens, you know, when you actually open any other window.
Oh, all right. So,
If you can unshare your screen and then share it again, maybe it will work.
all right, just a minute. And there you go. You should be able to see my screen now.
It's fine for me.
Yeah,
Can you confirm?
It's already working.
I'm seeing the debug window. I hope I am seeing the
yes,
right
yes.
one.
Yeah. Are you able to see the mouse
Yeah.
moving?
Okay.
Yeah.
Yes, I do.
Yeah. So I think we are on the same
Yeah,
page,
it's
everybody.
Yeah, same.
All right.
Yes.
It's on debug page.
Yes, it's on the debug page. You can see my mouse
It's
moving.
Yes.
Yeah. Yes, yes.
All right. So it seems that there was a temporary problem. Okay. So as I was saying, let me move ahead with this. As I was saying that we just wanted to verify how a while loop works. So we are here at the while loop. Where is that? Yes. So this is the while loop. I will put a breakpoint here and I will do a debug. Debug is done by F11. You can do it by F11, but as I want to show you guys, I will use uh, the key menus. So we are at the while statement, and you will see that right now the value of x is 0, and the condition that we are checking for is whether x is less than equal to 20. So as this condition is true right now, because x is 0 and it is less than 20, what will happen is that it will go inside inside the while block, and you will see, well, it just went too fast. All right, so it will go inside the block. You will see that it has reached inside the block, and once it goes into it, it will print this value, and it will increment it by 1. So it has already incremented it by 1. So you will see that the value of x is 0. No, it hasn't incremented it by 1. So the value of x is 0. And as I move forward, it will again take me to the while condition. After incrementing x by 1, it will again take me to the while condition, and it will again check for the this condition. So it says that the value of x is 1, but it is still less than 20. So I will again execute this. So you will go here and you will see that it has again come back to the same statement, and you will see that it has now printed the value of x also, because we are printing it here. So it has printed the value of x, and as we move forward, you will see that the value of x is turned to 2, but it is still less than 20. So like this, it will keep on happening till the value of x reaches 20. It will keep on happening like this. So you will see that this statement will be printed like quite a few number of times. Let me show you how. I will put a breakpoint somewhere here in the for loop, which I will explain in a few minutes. And when I run it continuously, you will see that it has executed the same statement 20 times, right? From 0 to 20, so it comes out to be 21 times. So it has executed this statement 20 times. So this is how we create a while loop. Now while loop has a condition here. All you have to do is just find out the condition that you want to use, and it will execute the statement that number of time. Now there is one more variation of while loop, which is do while loop. I will request you guys to try to understand it at your home. It will give you more understanding of the while loops. Similarly, we have another looping structure called the for loop. Now in the while loop, you will see for loop is little different than while loop. In the for loop, you see that we have initialized a variable earlier, right? And then we have used the variable, and then we have incremented the variable. And these are done in 3 different statements, 1, 2, and 3. Now in for loop, it has a more syntactically beautiful way of representing it. So for loop says, here is the definition. A for loop says that for initialize a variable, give me the condition around that variable, and once the condition and the statements are executed, give me a statement to update the variable. So what will happen is that for a variable, uh, understand it in pure English terms, it will say for a variable y which has a value right now as 0, I want to execute this statement till the time the value of y is less than equals to 20. And once you execute this statement, I want you to update it by 1. So y plus plus is equal to y plus 1. So this is how you read a for loop. For a variable of type this and an initial value of 0, I want you to execute this statement for till the time the value of y falls in under these conditions, and once this statement is executed, I want to update it by 1. So you will see that if I execute this, it will again print the value of y 20 times. Let me just remove the breakpoint, and if I run it, you will see that it has executed the same statement 20 times. So this is how you can achieve another looping structure just by using the for loop. So these were the two important looping structures that we have in Java. Any questions on these two structures? No questions? Laksh, am I audible to everyone?
Yes.
All right. All right. So this brings us to an end of loops. Now this is the while loop. This is the for loop that we were talking about. Any questions are welcome here right now?
Can I ask a question about loops?
Yes.
Um, can you have some example for enhanced loop for loop?
Enhanced for loop.
Yes.
What do you mean by enhanced? Like anything specific?
Yeah, it's like huh?
Actually,
Like
in Java, you have a third loop called as an enhanced for loop, and the syntax is a little different. So it's like for,
right.
and into the braces it says the condition and the expression.
Okay.
So the way to write the for loop is a little different for the enhanced for loop.
All right. All right. So okay. So let me just give me a minute. I haven't actually used that for quite a while now.
okay.
Just a minute. Let me just refresh my earlier usage thing, and I will. Okay. 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 So you are talking about. Okay. So actually, yeah, this is the plain for loop, right? So there is another for
Okay.
loop where what we can do is, let's say we have so that is actually a iterator. It iterates through, it iterates through every value inside a container, inside an array, or probably a collection. So I think this is the loop that you're talking about, right?
Yeah, exactly.
Okay, let's say I have an array of integer. Let's say the name is test array, and it is of length 10, right?
Okay.
Oh, okay. Well, this is the way we, not this, int 10, right? So let's say I want to I want to loop through every element inside the array int, right? Inside the array test. So what I can say, for int a inside test, I want to loop through every statement. Just a minute. It is giving me syntax error. Okay. So I have an older version of JRE available if source level is
Okay.
1.5 or greater. So I might not be able to
Okay.
show it to you here, but what it means is that
It's
let's,
okay.
all right. So I will just give you an explanation here. So what it means is that I have an array on the right hand side of this colon. It could be an array or a collection or or a collection of which implements a iterator. So iterator is again an advanced concept. You can read about it on the internet. So let's say it's a collection. I can say that for every element of type int inside the collection test, I want to I want to execute this statement. So for every element inside test, it will execute this statement. Let's say we have another array called string array, and string, and again it is of length 10. So if I want to write a loop against this, what I will do is I will say for every element of type string inside the array string array, I want to execute this statement. So this is how you represent, we call it advanced for loop. I wasn't sure about that, but yeah, this is the syntax of it. Again, it will execute the statement 10 times because 10 is the length of the array.
Okay. Yeah, that's great. Thank you.
All right, thank you. So we will move forward. Any more questions on this? All right, so let us move forward. So we have our next topic, which is inheritance. Actually, these are the topics related to the object-oriented design patterns. It's actually more related to the basic principles of object-oriented programming. So right now, it's only 10 minutes left to it. And if I go by these 4 principles, it will take more time than 10 minutes. But if I leave, if I explain only one and leave the other, it won't make sense. So probably we can pick it up in the next session. Is that all right with everyone? Does it make sense?
That's good
I
for
think
me.
that would make sense because we'll get a week. Yeah.
It's fine for
We
me.
would be able to practice what we have learned.
All right.
Yeah.
Thank you.
Fine.
All right.
Okay.
So, yeah. Yeah, so we will pick it up in the next session. And just after this, we would come up on our Selenium training. So once we are done with the object-oriented principles, we will move on to the Selenium introduction. And from there onwards, we will start writing some code for Selenium, against Selenium, to open our browsers and to do simple testing around it. So after that, after this Java basic, we are moving to the to our main part, which is Selenium. So I would request everyone to go through our tutorials. We will share these videos to you, and we will share some exercises, Java exercises, to you guys. I would request you to practice it. If you are familiar with Java, then that's all right. But I would request you to brush up your concepts. And if you have any questions, just let us know, and we will try to solve it. And after that, we will just move on to Selenium. There also, while programming in Selenium, we will come across couple of Java concepts, and we will explain them right there. All right. So, so we will stay here for another 30 minutes. If anyone has any question, feel free to bring it up right now. And those and the people who are all right and don't have any question, they can leave, and we can consider it as the end of the meeting right now. All right, so Karen has, I'm sorry, Mark, just give me a minute. Karen has asked what version of Eclipse we have to use. So I think the Eclipse Kepler version is the one we are using. So in the mail, we will specify the version also, and give you the details on where to download it from. Yeah, I think Mark was asking a question.
Yes. What can I have the video tutorial for the
So I'm sorry, Mark, please complete your statement.
like like where can I download the recorded session last night and for tonight?
All right. So we will be sharing you the link. Those would be available as a YouTube video, so you can stream it over the net, and we will share the links to you guys soon after the meeting.
Okay, thank you. And another thing is, a while ago you mentioned that you're going to share the projects you created
Yes.
so that you can study.
Yes. So I will share the
For
projects with you guys over the email.
okay, that's great. That's great. And I've noticed that there are some exercises there. Do we need to do it or perform it?
Yes. So there are exercises in comment section of every project. Plus, we have couple of more exercises which we will send across in the email as a document.
No, that's great. Okay, I'll just wait for it then. Thank you.
All right. Thank you.
Can I go ahead and ask
Thank
a few
you.
questions?
Yes, Neil, you can ask me questions now.
Yeah, there are two things which I wanted to talk about. One thing is while you were explaining about the abstract classes, you mentioned that abstract class is nothing but a contractual obligation.
Yes.
However, even if you see an interface, that is also a contract. So how can I exactly differ between these two?
Okay. So interfaces can be considered as nothing but pure abstract classes. Now, abstract classes, the one that I have explained to you, is not a pure abstract class because there was an implementation of one method inside it. Right. So, but an interface will have
Right.
no implementation. It will always have just the definitions of functionalities that anyone implementing that interface has to adhere to. So that way, abstract class is different from interface because abstract class can have implementations of non-abstract methods.
But then even whatever abstract classes are there in my interface, I have to override those.
In your interface, well,
I mean, when I implement that.
yeah, I'm sorry. Can you repeat the question, Snail?
Yeah, I was saying that like in abstract classes, whatever methods I am declaring, I need to override those methods, correct? When
Yes.
I inherit the abstract class.
Yes.
But when I implement an interface, is it a compulsion for me to override the methods from my interface as well?
Well, in interface has the sole purpose for the implementer of interface to override everything inside the interface. So there is nothing called overriding a method inside interface. Interface, the whole purpose of interface is that any class which is implementing it has to modify all the methods which are declared inside the interface. So, but in an abstract class, this is not necessarily true. For example, I will show it to you with an example. For example, this is my abstract class, and I have one abstract method and one non-abstract method. But an interface can never have a non-abstract method. So that makes it mandatory for whoever is implementing the interface to always have an implementation of the methods which are described in the interface.
Okay.
Right. So an interface I won't go on explaining interface, but I will give you a brief example because an interface would be something like this. There won't be a abstract keyword, but an interface would be like this. Every method would be an abstract method. Every variable would be an abstract variable. Well, interface will not have variables, but every method defined by interface will have this form. That means there would be no implementation. So whoever is implementing an interface has no option but to override the methods. So we won't say that the implementer is overriding the method. We will say that the implementer is actually implementing those methods. So whenever someone tries to implement this method, tries to inherit this class, he's implementing this method, not overriding it. Because if I say overriding would be when I have public void main method, and inside this method I have like int I equals to 0. So if someone redefines this method by changing the implementation inside it, that is what is called overriding. But if someone is trying to implement this method, this is pure implementation. It is not overriding. This implementation will be different in different classes, but it will be implementation. Anyone who's trying to change this method will be overriding, because this method already has implementation.
Yeah, I got that, but when you showed the example of car and the SUV, or I don't know, sports car or custom car example,
yeah,
in that your car had those abstract methods like start engine and open doors. Yeah, and then we actually, when you extended that abstract class car, you have, you're implementing it here, but you see the annotation @ override, this is nothing but it is overriding. It's like a must. You mentioned that we have to override these methods. So is that understanding correct? Or
yes, your understanding, your understanding is absolutely correct, and it says override here. It is also true that it is saying override, but in actual terms it is not overriding, because there is nothing to override to, right? So here we have this to override to. We have this implementation on which we are overriding, but here we don't even have implementation. We are just implementing it. So if you go by the actual the OOPS concept, the theoretical OOPS concepts, this is just implementing the methods, and this, if I redefine this method, this is overriding. Here it has shown overriding, override, which I'm not sure why it has shown, but in theoretical terms this is the meaning. But right now, for the sake of simplicity, probably we can say that yes, we have overridden it, but as far as I am concerned, I would say that it is actually implementing it, not overriding it. Did I confuse you more?
Okay. Now, whatever methods. No, actually, I'm a little bit not. I am not convinced with that @ override annotation, what it means and why it is there. So maybe we need to look into it more.
Yeah, sure.
Yeah, the other thing is like the abstract methods, which are either in my interface or my abstract class. Is it like at some point in time all the methods have to be defined somewhere in some of the subclasses, or can there be any method just left without overriding?
No, there cannot be a method which is abstract and is not overridden by the subclass. It is a mandate that
it has to be.
Yeah. So if I do this, just for an example, if I do this, I have removed one of the method. As soon as I do this, I will get an error. It says the type sports car must implement the inherited abstract method car.openDoor. So it is a mandate from the compiler that you have to implement all the abstract methods.
And will it be the same error in case of an interface also?
I don't have an interface right now. It should be something similar. Actually, I'm not sure about it, to be honest. I haven't recently defined an interface. So let us do it right now. Uh, Let me come up with an interface, and the name of the interface is iCar, and I will do a finish. And it brings me to iCar, and I will say that in this interface I want two methods saying public uh, car open, and it has to be of type void, and then let's say there is another method called public void car honk, right? Let's say I want to implement this, just a minute, I want to implement this in my another class, which is interface. I can say I want to add a iCar interface, and I would do this, and type name is empty, but yeah, I would say that Snail's car. This is Snail's car, and if I do this, so it has already populated with these two methods, and if I do this, it will again give me the same error message. Abstract method iCar.carHonk is not implemented.
Okay. Okay. So, so right now I just see that the difference between interface and abstract class is that my abstract class can have non-abstract methods, whereas my interface cannot.
Yes.
And it's like interface is nothing but you are implementing something, and yeah, that's all.
Yeah. Yeah, actually interface, the concept of interface arrived from, well, it is little out of topic. It arrived from component object model, where we had to call into external DLLs. So there, there was a mismatch between what we were calling into and what description of the method was there inside. And as the implementation changed, the call used to get exceptions. So that whole thing came from that era, where there was a need for having a contractual obligation between two different components. From there, this interface thing came up. But yeah, right now, if you were to design a really big system, then you would need a interface, and if you want to design it really well, you would need different interfaces. So, but right now, whatever understanding you have, it's good.
Okay. The other thing was we had talked about the access specifiers, right? And I had mentioned you one example.
Yes.
Wherein say I have a class 1 which is in my package 1. Okay, and it has either a default or a protected method defined there, and I have another class 2 in my package 2, and it extends my class 1 from package 1. Okay, can I still access my default or protected method in my class 2 now?
You can access the protected member, but you cannot access the default members. Actually, yeah, but do you want me to implement it right now, or
even if I'm extending the class?
yes, it's something like
yeah, I think
you
that
have.
we should try it.
Yeah, do you want me to try it? So before I try it, give me 2 minutes. I will just grab a glass of water. I will put you guys on.
Please go ahead.
Yeah, just give me like 2 minutes.
Yeah.
All right, so yeah, I'm back. So the question, well, Mark, it is still going on. If you have any question, you are free to ask right now. Right now, we are discussing about the Snehal's question, where her question is that let's say, let me start it in this project. Let's say we have two, like just let me add a package, sample package. So the Snail's question is, let's say if we have a class, Snail, it was an, okay, it was a default. Okay, so let's say we have a class, sample class 1, sample class 1, and in this class, let's say we have a default variable called int a, and then we have a protected
Can you
variable.
have a method there, please?
Yeah, sure. So let me have a protected member, protected method, protected void sample, and
a default method instead of a variable.
okay, a default method, sure, sample default. We have these two methods, right? This is the class, which is a public class, and it exists in sample package, right? Now let's say I want to add another class here, and the class is final class, let's say final class. Okay, so in the final class I will just import the package, which is sample package dot sample class, right? Now I want to extend this class, right?
Yeah.
Sample class 1. All right, so let me create a constructor around this, and I want to say this dot, and before we go here, sample class, sample void, sample is the method and sample default. Okay, let me close the classes. So here we would say sample is available to us, right? And the protected, this is the protected member, it is available to us because it was inherited. Now the sample default is not available to us. So as I said, the protected member will be available but not the default one.
Okay. Okay. And suppose my class is a default class.
Then it won't be available altogether.
For inheritance purpose also?
Yes.
Okay. Okay. Fine.
All right.
So Viren, I think like there are other people who are still on the call and they might need to ask some questions.
Yeah, sure.
You can give them a chance.
Yeah, sure. Anybody who wants to ask a question right now?
Hey Viren, we were talking about interface earlier, right?
Yes.
I see that you did not use an abstract keyword in that interface. So my understanding is, since in an interface always we have abstracted methods or variables, we need not specify the word abstract as such. Is that correct?
Yeah, it's correct to a point. Actually, the sole purpose of interface, you can consider abstract as a different keyword than interface as a different structure. So the whole purpose of these two classes, these two entities are to set up an obligation, but they are altogether different. So to define an interface, there are different sets of rules, and in those rules abstract doesn't come. So even if I put abstract there, it won't make any sense. So it's just the syntax. It's just the syntax. So interface doesn't mandate you to use abstract, but actually the meaning is something similar.
Okay. And in any of your framework design, have you guys used an interface, or your only inheritance would suffice for most of our requirements? Because I mean, in my previous places, I've never used any interface for my Selenium framework design. So I was wondering if that concept will be used for our framework designing or not.
Well, yeah. So as I was discussing earlier, interfaces are more related to different modules altogether. Usually, what happens is that our framework resides in one project only, right? So interfaces are required more when we have different modules which are completely independent, but they interact with each other. Okay, so let me rephrase it. So let's say I have two modules. One module is dependent on other, and those two modules are developed by two different teams, right? So what these two teams have to develop their projects at the same time, but it may be possible that the second team doesn't have the implementation of their program which the first team wants to use. So what they will do, they will declare some interfaces and they will give to the team 1. Team 1 will use those interfaces and implement their programming, but those interfaces, the real implementation of those interfaces are actually will be defined later on by the team 2. So this way team 1 can actually work on whatever dependencies they have on the team 2 without having the actual implementation, by just having the interface. So that way, you know, interface is just interface can be considered as a vague method calls that I have given to you. You can use them to program against, but I will give you the implementation later on as a form of a jar file or a DLL.
Okay.
These are very hard concepts to understand unless and until you actually write a program which uses it, and then you will understand what is the importance of interface. But at a higher level, this is what it means.
Okay. And one other question which I had is, I was just going through the content on the ToolsQA website for the classes.
Yes.
And I see that, one second please. I see that in a particular order it is being it's been updated. You are telling that, say, like we'll have WebDriver basics, and then we have WebDriver commands and stuff like that. So we will go in the same order, is what I presume.
Well, from Selenium, as soon as the Selenium starts, we will follow that order. We will try to follow that order. But as Java was concerned, we tried to move around a little bit based on the level of all the team members combined, and that's why there is a mismatch between some of the classes here. But I hope from Selenium onwards we will just follow a same pattern as mentioned on the website.
Okay, all right. Okay. Yeah, Virendra, I'm pretty much done with my questions.
All right.
And I'll catch up with you guys next week. Thank you.
All right. All right. Thank you for joining.
Thank you. Bye.
Bye. Any more questions?
Yes. Speaking of interface.
Yes.
Mr. Presenter.
Yes.
Actually, we're using the interface to store constant values and IDs and XPath. Would it be okay?
You want to use interface in your XPaths? I'm
Yeah, I
sorry,
mean,
Mark. I'm not able to
we
get your
use
question.
interface just to. Yeah, well, I mean, my question is it okay that we're using interface just only to store IDs and expats and some concept values, and we're just calling it up during coding?
Uh, well, to be honest, I haven't used it for
It's
storing constant values.
mm-hmm.
But I don't
Like
think so. Interfaces are meant to store values. They are just meant to give definition, a summarized definition of what your class does. So probably it doesn't have anything which will allow you to store values inside it.
uh, okay, and okay. Okay, I'm just thinking that since it will come to a point that such cases will pile up
Yeah,
um, when the project, yeah, I mean when the project goes on.
yeah.
Um, what how can I mean what can you suggest? I, I mean, like what I said to store values, constant values, and you know, do you get what I mean?
Yeah. So if I'm not wrong, what you're trying to say is that let's say the project size is increasing day by day. Now you have to, as the project size increases, you have more information to store for your tests. So you're looking for a efficient way to store that
Yes,
information. Is that
exactly.
correct? Yeah. So interfaces are not the solution to that. Probably you would want to, let's say there are 2000 tests, right? So in those 2000
Yes.
tests, you have different categories. For example, some would be functional tests, some would be your your unit test, or all those different types of tests. Some are related to payment gateway, some are related to the home page. So probably what you can do is you can have different config files or different data files for all these subsections, subcategories. For example, for home page you have different set of data file. For a for a functional test you have different sets of data file. So probably you can just scatter your data into different files so that every file is small in size and is manageable by your uh, by your project easily. But interfaces definitely is not the solution for that. Interfaces are
Okay.
more
Just
likely in your overall class designs. Interface is more like overall cross communication between classes in your framework.
mm-hmm. Okay, get it. Like the properties.
Yeah, like the properties file, probably you would want to store values there.
Oh, I see. I see. Okay. Well, that's it. Thanks.
All right, so any more questions? I have Mark, Karen online. So any more questions, Mark and Karen?
Oh, I'm checking my notes.
All right, sure.
Can you hear me?
Yes, I can hear you, Karen.
Can you hear me?
Yes, we can hear you.
Oh, no, I'm all set right now. Yes, all set. No questions right now. Thank you.
All right. All right. Thanks, Karen.
Thank you.
All right. So I think we don't have any more questions. Can we close this meeting for today?
Yes, I'll
Okay.
see you next week.
Yeah, sure. Sure. So thank you for joining, Karen.
Thank you. Bye-bye.
Bye.
Okay, thank you to Brenda and Mr. Lepshay.
Thank you, Mark.
Thanks
Thank
for
you.
joining.
Okay, good night.
Good night.
हाँ भाई
एक मिनट रुक जा, स्टॉप करने दे.